Ever wondered how cars can drive themselves without a human behind the wheel? Today on Knowledge Hub, let's break down exactly how self-driving cars work. Self-driving cars, or autonomous vehicles, are one of the most complex and fascinating technologies ever created, combining artificial intelligence, robotics, and real-time data processing to make decisions just like a human driver. At the heart of every autonomous vehicle is its sensor suite, which acts as the car's eyes and ears. These include LIDAR, light detection and ranging sensors that emit laser beams to map the environment in 3D radar systems that detect objects and measure their speed. Cameras that recognize traffic lights, pedestrians and road signs, and ultrasonic sensors that handle close-range detection for parking and obstacle avoidance. Together, these sensors create a detailed, constantly updating picture of the world around the car. Next comes perception, the car's ability to understand what those sensors are seeing. Using computer vision and machine learning algorithms, the onboard AI identifies objects like vehicles, people, and lane markings, then predicts their movement. For example, it can tell if a pedestrian might step onto the road or if another car is about to change lanes. This is made possible by deep neural networks trained on millions of real and simulated driving scenarios. Then comes localization, which allows the car to know exactly where it is on the map down to a few centimeters. It combines GPS data, IMU sensors, inertial measurement units, and the information from LIDAR to match its surroundings with a high-definition 3D map. This ensures the car always knows its precise position, even if GPS signals are weak or lost in tunnels or urban areas. Once the car knows where it is and what's around it, the next step is path planning. Here, advanced algorithms calculate the safest and most efficient route, factoring in road conditions, traffic, and even the behavior of nearby vehicles. The car must also be able to make real-time decisions, such as when to change lanes, yield, or stop for pedestrians, all without hesitation. Finally, the control system takes over. This part translates the AI's decisions into physical movement, steering, accelerating, and braking with extreme precision. It uses continuous feedback loops to ensure smooth and safe operation, constantly adjusting based on sensor input and environmental changes. All of this runs on incredibly powerful onboard computers capable of processing terabytes of data per hour. And because safety is paramount, autonomous vehicles are designed with redundant systems, backup sensors, processors, and power supplies to ensure they can continue operating even if one component fails. However, despite the advanced technology, full self-driving capability, known as Level 5 autonomy, is still under development. Most systems today, like Tesla's Autopilot or Waymo's vehicles, operate at Level 2 to Level 4, meaning they still require some human oversight or are limited to specific conditions. Self-driving cars represent the future of mobility, promising fewer accidents, reduced traffic, and greater accessibility. But achieving that future means perfecting the balance between AI, safety, and ethics on the road. If you've enjoyed this deep dive into the science of autonomous driving, don't forget to subscribe to Knowledge Hub for more fascinating explanations of the tech shaping our world. And as always, stay curious.